Hi. More problems related to trigonometric formulas. We know that cosine square alpha plus sine square alpha is 1. So in that case, we can say that cosine square alpha is 1 minus sine square, or sine square alpha is 1 minus cosine square alpha. We know the formula secant square is 1 plus tangent square alpha. So tangent square alpha can be written as secant square alpha minus 1, and the same cotangent square alpha can be written also as cosecant square alpha minus 1. So application problem, we're going to give you one of the trigonometric functions. We need to find the rest. The main one are sine, cosine, and tangent. Concerning secant is the inverse of cosine, cosecant inverse of the sine, and cotangent inverse of the tangent. So here you have secant x equal to 2 and x between pi and 2 pi. X, this is pi, and this is 2 pi. So from pi till 2 pi. Okay, so here either you are in the third quadrant or the fourth quadrant, but since you know that cosine is the inverse of secant, so if secant is 2, so cosine x is directly half. Since cosine is positive, we know that the cosine here, the x-axis here is negative, here the x-axis is positive. Since the cosine is positive, so we are talking in the fourth quadrant. This is very important to know. Now I have secant. You can use cosine and use this relation, or secant directly. You can use the relation of the secant, which is here. So secant square alpha equal 1 plus tangent square alpha. So secant square 2 square is 4. 4 minus 1 is a 3. So tangent square is a 3. But we know in the fourth quadrant, tangent is negative, so it will be minus radical 3. Now we know that tangent x is sine x over cosine x. We have cosine x, which is half. We have tangent x, which is minus radical 3. So cross multiply. So in that case, sine x will be cosine times tangent. Cosine times tangent, it will be minus radical 3 over 2. Now they gave us sine, and it's between pi over 2 and 3 pi over 2. So it's either in the second or the third quadrant here. But since sine x is negative, we know that here sine x is positive, the y-axis. Sine x here is negative. So we are talking in the third quadrant. So I have sine. You can use this formula. Cosine square x plus sine square x is equal to 1. So cosine square will be 1 minus sine square. So sine square, if you square it, will be 1 over 25. If you do 1 minus 1 over 25, same denominator, which is 25, you're going to get 24, 25 minus 1, 24 over 25. And since in the third quadrant cosine x is negative, you're going to get minus square root 24 over 25, which is simplified to minus 2 radical 6 over 5. We need to find tangent. Tangent is sine over cosine, so minus 1 over 5 over minus 2 radical 6 over 5. 5 and 5 cancel out. Minus over minus is positive, so it will be 1 over 2 root 6. Now we have it from 0 till pi. And since tangent of x here, as you can see, it's positive. So here the tangent is positive, here the tangent is negative. So we are talking in the first quadrant. So we have tangent, we can use this formula. So secant square alpha equals 1 plus tangent square alpha. So 1 plus tangent square is 9. So secant square is 10. Secant is the inverse of cosine. In the first quadrant, cosine is positive. So it will be plus radical 10. And the cosine is the inverse of this one, which is 1 over radical 10. We know that tangent is sine over cosine. This is a 3. This is 1 over radical 10. So cross multiply, you're going to get 3 over radical 10. Now cosine x, first of all, between pi over 2 and 3 pi over 2. Here is 3 pi over 2. So cosine x is negative. We know that in the second and the third quadrant, cosine is negative. So it can be in the first, in the second, or in the third, in both. So we start, we have cosine x, we use this one. So sine square x equal 1 minus cosine square. So 1 over 9, same denominator. 9 minus 1 over 9, so 8 over 9. Sine. Since it can be in the second here sine is positive, in the third sine is negative. So we have two choices. plus or minus 2 radical 2 over 3, and tangent x is sine x over cosine x. If we divide this one by 1 over 3 minus 1 over 3, 3 and 3 cancel out, it will be plus or minus 2 radical 2. So here we have two choices for each. Simplify, we use this property, don't forget this property. Sine x secant x, sine x secant x cosine x into 1 plus tangent square x. I want to simplify the maximum I can. We know that sine with secant is 1 over cosine. Okay, so secant is 1 over cosine. Let me write it. Sine secant is 1 over cosine. Cosine, so cancel both. What remains? So it remains 1 times sine x. Here I have sine x, sorry. So sine x, 1 plus tangent square, you can know this is secant square x. So you're going to get sine x over cosine square x. So here we cannot do anything. So it's sine x over cosine square x. So 1 plus tangent square x is secant square x. Secant and cosine is the inverse of each other. It's 1. So you're going to get sine into secant square x. You can keep it as it is. You can write it either in sine over cosine square, or you can say it's sine x into secant square x, because I cannot simplify anymore. Now 1 plus cotangent square x is cosecant square x, and we know that cosecant square x is 1 over sine square x. So sine x times 1 over sine square x is sine over sine square. Now sine and the square cancel out, it would be 1 over sine x, and we know that 1 over sine x equal cosecant x. Here we know that cotangent is cosine over sine, tangent is sine over cosine. So cotangent times tangent is 1. Cosine x over sine x, and tangent is sine x over cosine x. So all simplify to 1. So 1 minus secant square x, you know that 1 minus secant square x is equal to minus tangent square x. So here you have minus. Okay, 1 minus tangent square x. Now, sine square cosecant secant. Cosecant is 1 over sine, secant is 1 over cosine. So square and the sine get rid of. So you're going to get sine over cosine, which is tangent x. Now, we know that 1 plus tangent square x equal secant square x. Okay, so secant is 1 over cosine square. Cosine and the square get rid of. So 1 over cosine x is secant x. Secant cosine, secant is the inverse of cosine. Secant is 1 over cosine times cosine is 1. 1 minus cosine square x, 1 minus cosine square x equal to sine square x. Here 1 plus cotangent square x equal cosecant square x. Cosecant square x. So it's secant over sine, and we know that secant is 1 over cosine x, and cosecant is 1 over sine square x. So as you can see here, we cannot simplify anymore. So we keep it as it is. It will be 1 over cosine x into sine square x. Okay, so 1 plus cotangent square x equal cosecant square x, and cosecant is 1 over sine square times 1 over cosine x. We cannot simplify it, we keep it as it is. Now we have cosecant, cosine and cosecant. Cosecant is 1 over sine. Okay, so here you have cosine x, cosecant is 1 over sine x, and down you have cosine x, cotangent is cosine over sine. So what do we do? So this sine x and that sine x cancel out, remains cosine x over cosine x, which is 1. Here 1 plus cotangent square x equal cosecant square x. You can see it here. Okay, you have sine square and you have the secant x. So secant x is 1 over cosine x. Cosecant x but square is 1 over sine square x. and you have sine square x. So sine square over sine square cancel out. So what remains? 1 over cosine x, which is secant x. Now we know that 1 minus cosine square x is equal to sine square x. And we know that cosecant square x is 1 over sine square x. Times sine square x up, it will be directly 1. So these problems are very simple. Cosecant is 1 over sine. Sine times 1 over sine is 1. 1 minus cosine square x is sine square x. This is simple. Now cosecant is 1 over sine, and the secant is 1 over cosine, and tangent is sine over cosine. So cosine cancel out. Sine and sine square remain sine up. So you have sine x up and sine x down. Sine x up and sine down, it's equal to what? To 1. Now we want to prove the identity. So you have right and left. You want to show that this equality here equal to that equality here. Proving. Also, we're going to use the properties. A plus b square. You all know a plus b all square is equal a square plus 2ab plus b square. So binomial property. So sine square plus 2 sine x cosine x plus cosine square. We know that sine square plus cosine square, is it equal to 1? I'm asking myself. I must get a 1. Sine square plus cosine square is 1. This is the formula here. Plus 2 sine x cosine x, and I have minus 2 sine x cosine x. So these two cancel out. 1 equal to 1, it's approved. So it's 100%. This equality is true. Now I want to show that cosine x times cotangent x is the same as 1 over sine x minus sine x. We know that cotangent x, you all know it's cosine x over sine x. Here I have over 1. So I do same denominator, which is sine x. So it will be 1 minus sine x times sine x is sine square x. I'm doing same denominator because I need to get down sine x. Not to change anything, I multiply up and down by sine x. So when you have same denominator, you can add the numerator. So it will be 1 minus sine square x over sine x. And I know that 1 minus sine square x here, it's cosine square x. Cosine square x sine x. And here I have the same cosine square x over sine x. So both are equal, so I have proven. Now I want to show this one. What's cotangent x is cosine x over sine x. Sine and sine cancel out, so cosine x equal to cosine x. It's also proved. Secant is 1 over cosine. Okay, so I have sine over cosine, x tangent x, 100% it's true. Now I want to show that cotangent x equal cosecant over secant. I know that cosecant is 1 over sine. We know that secant is 1 over cosine. So if you multiply, this is the ratio, you know it, or times the inverse, you're going to get uh, cosine x over sine x, which is the same as cotangent x. Here, I want to show this one, so I'm going to start by this one. So we know that sine square over tangent square is sine square over cosine square minus sine square. So I have it over 1. I want to do same denominator, which is cosine square x. So I multiply up by cosine square x and down by cosine square x. So what do we get? Sine square minus sine square cosine square over cosine square x. You can see here, you can put in factor sine square x. So if you put sine square x, what remains here? 1, and here minus cosine square x over cosine square x. Now we know that 1 minus cosine square here is sine square. Sine square, this is sine square, times sine square is sine 4x over cosine square x, which is the same as this one. Why it's the same? Because tangent square is sine square over cosine square. Sine square times sine square is sine 4 over cosine square, which is 2, so it's already proved. Here, we expand, we multiply this by this distributive property. So sine x cosine x tangent x plus sine x cosine x cotangent x. I want to prove it if it's equal to 1. Now we know that tangent is sine over cosine and cotangent cosine over sine. So cosine cancel out, remains sine times sine is sine square. Sine and sine cancel out, so cosine square. Is it equal to 1? Yes, this is the formula, the fundamental formula. Now I want to prove this one, so let me do cross multiply. Writing this one is the same as writing it of that sort. So it's a minus b into a plus b. We all know it's a square minus b square. So it will be 1 minus sine square x equal cosine square x, 100% true. 1 minus sine square x equal cosine square x here. Now cosecant we know it's 1 over sine, cosine, tangent is sine over cosine. So sine and sine cancel, cosine and cosine cancel. It's equal to 100% true, we have proven. So this one we start with it, one similar, this one and that one are similar. So cotangent square is cosine square over sine square minus cosine square x. We do same denominator, which is sine square, as you can see. So I multiply here by sine square. Then I put cosine square in factor. If you put cosine square, you're going to get 1 minus sine square. 1 minus sine square is cosine square. Cosine square times cosine square is cosine 4 into sine over sine square. But we know that cotangent here in the beginning, no need to do it because it's very obvious. Cotangent is cosine square over sine square. So it's the same over sine square. So it's the same. So it's already proved. Here, it's a plus b squared, so a squared plus 2ab plus b squared. So we know that cotangent square x plus 1, cotangent square x plus 1 equal cosecant square x. So cosecant square x plus cotangent square x, so I have this equality, so it's the same, so it's proved. Here the same as we did up. Tangent square is sine square over cosine square over 1. I do same denominator, which is cosine square. So I multiply up and down by cosine square. You have this one to do same denominator. Here you can put sine square x in factor. What is left? 1 minus cosine square over cosine square. We know that 1 minus cosine square is sine square times sine square is sine 4x over cosine square x. So it's the same as this one. Why it's proof? Because tangent square is sine square over cosine square. Sine square times sine square is sine 4 over cosine square. Here secant square is 1 over cosine square. Okay. And secant and cosine are the inverse of each other. So secant square is 1 over cosine square times cosine square is 1. So we can do same denominator. So 1 minus cosine square over cosine square, and 1 minus cosine square is sine square over cosine square, it's tangent square x. So it's proof because I want it to be tangent square x. So that's it. As you can see, this section is very simple. So be ready and prepared for Monday.